This is day 15 of Advent of Code 2024 Done and Go, and this challenge is called Warehouse Woes. You appear back inside your own mini-submarine. Each historian drives their mini-submarine in a different direction. Maybe the chief has his own submarine down here somewhere as well. You look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini-submarine over to see if you can help. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movement, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of movements the robot will attempt to make, the puzzle input. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. So for example, if we have this and all this, as the robot, the @ symbol, attempts to move, if there are any boxes, which are O, in the way, the robot will also attempt to push these boxes. However, if this action would cause the robot or a box to move into a wall, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you. The rest of the document describes the moves: up for up, caret for up, V for down, less than for left, and greater than for right, that the robot will attempt to make in order. The moves form a single giant sequence. They are broken into multiple lines just to make copy-pasting easier. New lines within the move sequence should be ignored. So here's a small example to get started. Were the robot to attempt the given sequence of moves, it would push around the boxes as follows. So the first instruction is to move left, but there's a wall there so it doesn't move, and then goes up, so it's now here, tries to go up again but there's a wall, goes right, so it pushes this one to the right one and moves, go right again, and it's pushed both of them to the right, tries right again, doesn't move, tries to go down, so it pushes all of these down, tries to go down, wall, left, fine, down, fine, then to the right it goes, pushes it, pushes again, goes down and moves, and so on. The larger example has many more moves. After the robot has finished those moves, the warehouse would look like this. So everything pushed around like that. The lanternfish use their own custom goods positioning system, GPS for short, to track the locations of the boxes. The GPS coordinates of a box is equal to 100 times its distance from the top edge of the map plus its distance from the left edge of the map. This process does not stop at wall tiles. Measure all the way to the edge of the map. So the box shown below has a distance of 1 from the top edge of the map and 4 from the left, resulting in a GPS coordinate of 100 times 1 plus 4, 104. The lanternfish would like to know the sum of all boxes GPS coordinates after the robot finishes moving, and in the larger example, the sum of all box GPS coordinates is 10,092, a smaller one, 2028. So what is the sum of all box GPS coordinates? Okay, that sounds interesting, so let's get started. First we'll look at the instructions. Okay, so with all this, the first thing we'll do, we'll call this split, and then we'll split on new line, new line. So we'll have this first, and then split on new line, we'll have instructions. So we need to create a grid. This will be make ray rune with length of split 0. Oh, that should be len. Now what we need to do for I line in range split 0, we then do grid I is equal to rune line. But what we should also do is find out where the current position is. So we'll do we're going to do for j equals 0. J is less than the length of line j++, and we will do a type struct. So type point struct x int y int. Okay, no, alright, no comma. So we do that. Okay, right, I need to. So it's not just this, I need to do strings split. Was it field? Wait, which one should I be doing? So I've got all this. Yeah, okay, string split this on new line. Cannot convert line variable of type string to type rune. Okay, what did I do on the other grid ones? Ah, that's what I did. There we go. So we've now got this, and we do if line j is equal to at. Actually, I forgot about this. So we do we'll do position is equal to struct. Actually, we'll do this first, and then here we do if equals at position is equal to, and it shouldn't be struct, it should be point, and it'll be I then j. Then we do that, then we can break, and let's see pos found equals false equals true, if not pos found, and we'll chuck that into here. Actually, for some, just so we can remember what this is, we'll name it robot, so we clearly see what it is. So I've done this, got this. We now need to go through this here, so it'll be the exact same thing. This one doesn't need to be I, just have line, split on the first, and we'll have instructions is equal to list of runes, like so, and it'll be for, so underscore instruction in range line instructions equals append instruction. So I've got that. Now we need to do this, create the mapping for this. So we will do directions is equal to map rune return ints, like that. So we do caret, this will be equal to -1 0. Then we do the others, so right down left, this would be 1, no, this would be 0 1. Might be doing the numbers wrong. Okay, so if we're doing x and y, it might be a bit confusing. This actually point, we'll use this green return point. So x would be 0 and y would be -1. So right would be 1 0, this would be 0 1, and this is -1 0. So we should probably check to see if this is working. So we'll go to here, format.print line robot.x and robot.y. We'll then print grid, let's just print the first 10 lines, and then instructions, print the first 10. Declared and not used, directions, sure, we'll just print directions in here. 24, 24, let's see where we are. That looks to be correct, and that appears to be saving the grid right, and assume this is correct for the symbols. Let's take a look. Up, up, left, up. Yeah, this seems to be correct, and the mapping is also correct, I think. Do we have, what is 118? Okay, well, anyway, that seems to be correct, so let's go with that. So, what we need to do now, we go through the instructions, we go to where we are, we look in the direction that we're facing. If it's a wall, do nothing. If it's a box, we then need to follow along, seeing how many other boxes are, and then we need to push it, but also checking to see if the one after it is a wall. So if you've got box, if the next one's box, keep going, and then if it's a wall, do nothing. If it's a space, push it all up. So that's how we're going to do it. So I've got all this, we'll bring the output up to the top, so you're out of the way. Now we do for instruction in range instructions, we'll do is equal to directions instruction. Now let's, just to make sure this is working, format.print declared and not use robot. Sure, let's just chuck robot in here so get rid of that error. Okay, cool, that is working. So because hashes surround the border, we don't need to check for any out of bounds type stuff. So what we do, next position is equal to point, and this would be robot.x plus dir.x and robot.y plus dir.y. Now we do if grid next position.y next position.x is equal to hash continue. Now we'll do else if this is equal to a dot, we'll do robot is equal to next position, but then we'll do grid robot, no, what we'll do is up here, then robot.x is equal to dot, We do this, and then we do this. And now we'll do else if this is that O or 0? Okay, that's an O. If it's O, we then need to do 4. What should we do here? Let's do next. What are these things called? Next box. Next box is equal to next position, and for nope, this is going to be position, a point. This dot x is going to be this. That's what I'm trying to do. But instead of robot, it's next position, and we will do 4. This is still equal to that. We will then just keep adding to it, but this is now equals point. Next position is this. Now we do these condition again. If grid next box is equal to hash, continue. Else grid this is equal to O, and then we do this. That should be like that. And I think that's all that needs to be done for moving it. So from our current robot position, so I've got robot, we're moving our direction in a way. If the grid position is a hash, it's a wall, we do absolutely nothing. If it's a dot, we simply move there by making our current position a dot as we're moving away from it, making robot. Actually, it will probably be better to do this, just in case there's any type of reference issue. I'm not too sure. So make a new point, which is that, and then we do this. Otherwise, if it's O, we're going to be checking for the next location. And we're going to be keep doing this while it's O, so we're trying to find the very end of the chain of boxes. If the very end is a hash, we don't move at all as we can't push it. Or if it's a dot, we just swap the boxes in front of us, we just swap that to the end. I guess that's what we're doing here. Just setting next box, changing that to 0. Our current location goes to dot, and where the box was, I will also do this. We then change it to our location. So what do we actually do for the condition? That's this. So I guess that's just iterating over the grid for we'll use which values are times. So okay, we'll use y for y equals 0. No, we may as well just stay with 1 because 0 will never be it. Y is less than length of grid y plus plus, and for x is equal to 1, x is less than length of grid y x plus plus. If grid y x is equal to O, output plus equals, and it's 100 times y plus x. And we will first test on this test input just so we can make sure. Whoops, I accidentally put all this code into part 2. So let me just quickly swap this all around. Okay, I've rewritten it so it's now in the part 1 function, so let's run it again. Got 1624. Was that the output it had? Doesn't seem to be the case. Maybe I should also just print out the grid. Let's see what that looks like. Interesting. So I've set this up wrong, obviously, and I'm pretty sure I know why that's... This needs to be... Need to split it and get the length of this. It's not the issue, but it's something. So let's do for line in range grid format dot print string line. Okay, that looks... yeah, that's not right. Okay, I'm gonna have to copy this, put it into here. Let's print here as well. What are you printing? Need some debug information. Okay, we'll print string instruction robot, and we'll print, put this below here. Let's do robot string instruction and then direction. So if we go back to the top, let's see how this compares. So that looks correct. Starts here, move to the left, doesn't do anything. Move up, so that's the current state. Move up, it did go there. Move up again, didn't do anything. Move right. Okay, that didn't work. Maybe I need to change this to else. Does that change anything? Okay, that did change it. Why did... next box. Okay, we've now got that. Let's switch back to the real input. Oh, didn't consider all those prints. Let's just comment this out and rerun it. Okay, we've got... Well, that's 1 million something. So let's submit that. And we got the right answer. So let's now go on to part 2. The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, Reports are coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There is one key difference. Everything except the robot is twice as wide. The robot's list of movements doesn't change. To get the wider warehouse's map, start with your original map, and for each tile, make the following changes. If the tile is hash, the new map contains hash hash. If it was an O, it's now bracket bracket. If the tile is dot, the new map is dot dot, and if the tile is at, it's now at dot. This will produce a new warehouse map which is twice as wide and with wide boxes that are represented by 2 brackets. The robot does not change size. The larger example from before would now look like this. Because boxes are now twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they directly push 2 other boxes at once. For example, consider this situation where there's box box. After appropriately resizing this map, the robot would push around these boxes as follows, like this, and would push it 1 dot to the left. And if you move down, down, left, left, and up, okay, it would push all of them as they're connected. Then you move left, left, up, up, it would push that. This warehouse also uses GPS to locate the boxes. For these larger boxes, distances are measured from the edge of the map to the closest edge of the box in question. So the box shown below has a distance of 1 from the top edge of the map and 5 from the left edge of the map, resulting in a GPS coordinate of 100 times 1 plus 5. So I think that's the same measurement from the edge of the map to the closest edge of the box. So it's still 1 from top. Alright, and the closest edge to the box, so this would be the left, or if you're going to this way, or the right if you're going this way. In the scaled up version of the large example from above, after the robot has finished all of its moves, the warehouse would look like this, and the sum of the GPS coordinates is that. Okay, interesting. So we'll start off with copying everything, and we now need to change how the grid is created. So is it appears to be the same height, it's just the width. Yep, that seems to be right. So this stays the same, and now we need to change this. So we'll do grid line is rune, then we'll do for r in line, and we'll scrub the rules which they have for this, and we'll do if r is equal to hash, grid line equals append hash hash, else if o opening bracket closing bracket, if it's dots then it's just dots as well, and now if it's at, it'll be at dot. I'm not exactly sure what this error is. Oh right, I forgot range. There we go. Then we do, so I've got grid line, which is this, then we do grid I is equal to grid line. Okay, we can add this condition into it. So this robot equals point I. Oh, I may have got lucky with the first one, because I was for the Y coordinate. So I think this would be length of grid line, then it would be I. I don't need this break anymore, don't need this position found, get rid of those. But what I definitely need now is to print out what it looks like once it's built. So let's run that and see. Actually, we are going to use the test input. That does look to be correct, what we got. Can we find, is that one? That does look right. Okay, maybe we try this test one. So that was 1092, and we've got that one, and that looks to be correct. Okay, so we've got all this. We now need to change how this is handled. So this is the same, this is the same, it's the boxes that we need to change. So we need to do if it's this one or this one. So the way we do it would be, if it's this, we need to go to the right one. If it's this, we need to go to the left one. We'll do left box var left box point and right box point. And we'll do if it's this, left box is equal to this, and right box is equal to this plus 1. Else, right box is this, and then left box is this minus 1. Actually, what we're going to do is we are going to do boxes, and this will be a list of points. A list of 2 points. So now what we do is, if it's like this, don't need these, boxes equals append, and it would be 2 point, and it would be this and this. Otherwise, it would have been this one. So -1, and keep like that. And we are going to add boxes to this. Although we are going to do a next box, and this would be... Actually, is there a rule for how the boxes push? Because let's say you had like a staircase of boxes where it's like this one and then this one, and then imagine there was a box here and here, then a box here and here. Would they all push? Okay, so it says can directly push 2 other boxes at once. When I read that, I was thinking, so it can only push 2 boxes, but I think it meant a situation like this. So there are multiple conditions we need to look for. So box is equal to this. Oh, does that mean you could stack up? You have a box, and it's pushing 2 boxes, and then these... No, wouldn't be able to... you could kind of like a pyramid of boxes that gets pushed. Oh, I'm thinking of just how we're going to have to actually push all of them instead of just swapping the last open space with the box. Okay, that's annoying. Okay, so after doing this all works. That's all fine. Got this. Okay, next box. So at this point, your robot is only able to push 1 box. But we are going to have to change that so it's like this. So we know the rows are being pushed. So, in each row there could be multiple boxes. We need to check to see if there's any boxes in front of them. We then need to see if there's any walls in front of them. So next box, so will be this. We need to go through all of them. So we need to... It's difficult to just think of just exactly how to write this. Let's do wall found, box found equals false. Okay, well I guess you can... Wall found equals false, box found equals false. Need to add these in. So what's going to be happening is we're going to keep iterating, and I guess this would be for box found is equal to true, or wall found is equal to false. So we'll then loop over, and then if wall found, continue. Otherwise we then move all the boxes up. But while we're doing this, for box in range boxes, so it wouldn't be boxes, next box. I'll do box next pos is equal to, no, we need to do another loop. For box pos, okay, we're going to change this. Okay, we're going to put this up here. Current box, actually we can bring that down to here. Current box is equal to boxes 0. So for this, so for box, current boxes, in current boxes. So I've got a box, and then we can do next box, which would then be the next boxes. So for current box position, actually no, we don't need to loop over it. Okay, wait, we do, so we've got the box, do this, I've got to put range here, then we can do if box 0, okay, now we need to do this, grid box y plus dir dot y, then box 0 x plus that. If this is equal to opening bracket, then next boxes equals append, then it'll be, okay, what's going on here? Why doesn't this work? Well, I'm just going to copy this for now. So this would be append this. Oh, maybe this one, there needs to be an extra curly brace. So like this. Okay, there we go. So back to here. So this is box X. Wait. Okay, in this scenario, it's the top one. So then this plus 1. So if it equals that, then we do this. Otherwise we do else if... No, we do that, then we continue. Now there's the extra condition of multiple. If it equals this, then this is -1, and this is 1. And then we need to do on box 1, if that is equal to the opening one, we then do this first condition. Okay, so you have what we're doing here. We're checking on, so we've got the square brackets. We're checking on this one. If the one above it is the exact same symbol, then that means the one above that is this. So it's one box in a straight line, and that's how we're adding it. Now for this condition, we're doing, okay, we've got this box here and here, but above it is this. That means the box is like that. So we're adding this one onto it. First doing the -1, and then the current position right above it. And for this, we're doing the exact same thing. Got these, but then it's above here like this, so that would be like that. Although of all this, I should also do if this is equal to hash, or this one, but 1 is equal to hash, wall found equals true, break, and I guess we should also make this is equal to false. So then that breaks. We would get to here then. Okay, I'm covering this part already. Would then get to here, full found, continue. Otherwise we then go through and push the boxes. Okay, so I also need to do, what do I have the boxes saved? Boxes, when we get to end of a for loop, boxes equals append next boxes. And current boxes is equal to next boxes. So we could change this, instead of using boolean box found, length of current boxes is greater than 0. So do that, and wall found. Wall found is false, or just do not wall found. So the moment one of these is broken, so if this is true, then we found the wall. But if this is false, as in true as in the wall is found, but if the wall has not been found, and this condition is broken, that means everything in front of us is now a dot. So I think for that would be, I don't know, for box row in range boxes, for box in range box row, we would then do grid box dot, okay, what are you, box? You're a point, yep, so box y plus the y, then box box dot x plus the dot x is equal to this, and box 0, that's where I was going wrong. Just want to double check, so box 1 dot, there we go, and box 1 is equal to this. And then lastly, trying to find from the old one, okay, where is, okay, up here. We would then need to handle this as well. So we've moved all the boxes, and this actually needs if length of boxes greater than 0 for this section, and then for this we do this part. Actually we would have to do robot x plus dir x, and same thing again but y. Okay, so we've done that, now we need to figure out this. So for this one, we'd always be going, it would always start with this one. So we now need to figure out how did this work again, the actual calculation of it. The box shown below has a distance of 1 from the top edge of the map and 5 from the left. Distances are measured from the edge of the map to the closest edge of the box. Okay, they should have used a different example. So for these larger boxes, distances are measured from the edge of the map to the closest edge of the box in question. So the box shown below has a distance of 1 from the top edge of the map and 5 from the left edge. So is this one ever calculated? I'm going to keep it as is. I'm going to do this, and then it would be x++. So I want to run this and just see what happens. Undefined box found. Yep, that sounds about right. Need to get rid of that. Okay, so we've got an infinite loop. That's probably, okay, not here. Is it here? Okay, what are you current boxes? Why are you going forever? Okay, well, we're on instruction 62, so maybe it is working. It's just taking a long time. Let's put it here and see what happens. So still 62. Okay, what box are we looking at? So box, we're on this 10 y 10 6 11 6. See what's going on. Let's add these to it. Okay, there's a logic flop done somewhere, but I'm not sure where. Okay, I think what I need to do here is print out what the grid looks like at the beginning of each iteration of this. So let's do that, and maybe we can find something that's wrong with it. Actually, we're going to switch to the easier version so we can verify what is going on when we look at it. So let's do that. So let's go to where it gets printed, and if we look at it, it starts off like that. We go to the next one, it's the same, which is correct. Was trying to move left. Okay, that just broke straight away. Let me change, I need to include the direction within it, so it makes it a bit easy to understand what's going on. So we're trying to move left. Now we're trying to move left again. Is there 3 lefts in a row? No. Wait. Okay, I need to rerun that. I need to rerun that. I don't think... So it's meant to actually be pushing it now. I don't think it did though. Well, I need to check closer on it. Okay, I've got this printed in the wrong spot. I need to have this printed here, because that's when I've actually moved things. Okay, well that's very wrong. So something I didn't consider is with this, it's actually being moved when it gets moved, it moves 2 spots. I think. If it's, no, it doesn't. It gets removed once. Okay. Well, I need to slow it down. And it's just printing it all in one go instead of going to the breakpointer set. That's cool. Okay, so we're here. Let's print it once. Started off there. And it's going to the left. So it went, I'm not sure how it teleported down there. But this is a start. So what logic are we using? So whereabouts is it that we're pushing? I'm not sure how this became wrong. Actually, I do have next position here. I should just put this back. So I've got next position in. And this is us trying to push it. Okay, I'm going to put this in. So I can see what exactly changes with each of this. And then we'll also put this here. So for each box run like that, let's go. So we'll show the initial print. We're going to the left. We're here. So I think what should happen is this overrides this one. Okay, well, nothing changed just yet. Okay, I guess maybe because... Actually, I'm not sure why that happened. Yeah, let's look at the next one. So it's kind of pushing, but it's not really. And then that moved over correctly. Okay, let's go back to one of the breakpoints I did. Let's format.print. We'll do this, this, and this. Then we will also do this, this, and this. Actually, I should also do this one so we've got everything. And we'll also include this in it so we can see what's actually being changed. So we are now here. So we are Y position 3, 3. So that's both of them on 3. That's correct. This one is 7, 8. It should have been changed to 6, 7. Or in other words, these two should have been updated. But that didn't happen. What happens... why didn't that update? For curiosity, I'm just going to switch these around. So let's go back to where we were. Okay, so we're actually looking at this one first. No, that one changed. Why did that change? Okay, I think my logic for looking at these is wrong. Oh, this part is. So my assumption is wrong with this, I think. Maybe? No, so a box can only be left and right. I was going to say maybe you need to multiply it, but that doesn't make sense. Okay, let me go back to this breakpoint. What do we have in boxes? Why do we have 4 items in here? So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think I've messed up how this is being done. Okay, this logic is wrong because it was based on... I was thinking of it like vertically, so if you're pushing it vertically and there's the square bracket here, this would be true, but horizontally they push fine. So I might need to add a condition here. If dir.x equals 0, then this one would happen. Okay, now there's so much to my logic that is wrong. Because I'm only looking at the left one, but if we're going to the right, the next one in front of it is this. Oh, I've complicated this for me, I think. Okay, let's see if... Might need to change it so it's like if instruction is equal to caret and do stuff like this. Actually, let's copy this and just undo what we did then. Let's bring this back. This code might work for the verticals, but then for the horizontals, we have to change it. So we do this, and let's copy and paste all of this to the top. And I forgot that little bit at the end here. So for the horizontal, it's purely just, it doesn't matter which symbol it is. It's just if, okay, we need to do, so if we're going to the right, if grid 0, this is equal to this, then we'd have to do else. Then we could do if 1 is equal to that. Oh, and this +1 is wrong as well. So this would be not +1. This should be ×2, and that should also be the same for here, and same thing here, ×2. Okay, I did have -1 +1, but okay, looking at this now, I'll do ×2 here as well. Something I didn't consider is the at for this one. The at could be else if this condition, but it's no. I don't need to do that. We've already established this box has been pushed. I was gonna do condition for if it's pushing the right one, but no, this works. So I think that's good. Now for this, if we're going to the right or left, we're checking to see if the one directly in front of us is equal to that. Else, if it's this, same thing. Oh, I think that might be all that's needed. Okay, well, let's just run it and see if we've got something that kind of works. No, not exactly. Okay, yeah, that's still broken. Okay, let's go back to the beginning. So we are here. What boxes do we have? We have 2 boxes, which is correct. No, we don't have a box recorded. Okay, so that means we need to go back to here. So we've got current boxes. We have this one box, which is 0, 1, 2, 3, 4, 5, 6. That point isn't correct, is it? 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've recorded this wrong because Nexter already has the value in it. Yes, okay. There we go. So let's save that and restart it. So if we go to here, current boxes, 8, 9, there we go. So let's get rid of this breakpoint and see what this does. So that hasn't done everything, so I'm hoping, don't know what it's done. Okay, so it messed up, although it was very close. So it's kind of right, it just did this the wrong way round. So that would mean there's now an error here, wherever I've got the printing. Ah, that's right, I switched these around. I was gonna say I better not forget, and I did forget. So now let's run it, and I removed that breakpoint, so we should see the full thing run. Okay, let me stop this. This should be this. Okay, where do I have prints? So let's get rid of all this for now. I don't want to see every single movement. So we're here, runs once, and then it looks like that, which is wrong. I've got no clue how that ends up there, because that makes no sense. Am I doing something with next position? That's weird. Well, let's see what it does on the next one. Okay, that is very wrong. Okay, let's take a look at it more clearly. So going to the left. What? Oh, I think for the person direction. Where are you at? I put it in the wrong location, maybe. What for loop is this? I might need to print this out, see what's going on. Okay, so pushes once, does that. Okay, now it seems to be working a bit better. And then this messes up. I've got no clue how it's messed up that badly. But at least we know something is messing up. So that is for the verticals. Where's that code? That's here. Okay, maybe get rid of this times 2. Okay, I just need to run it slowly, line by line. Don't want to do that, but we have to. Okay, I didn't mean that. Okay. Okay, I don't need to actually print out the lines like that. Okay, so now let's go. Doesn't equal dot. It is a grid. Is the one an open bracket? No. So we go to here. Next position is 9, 3. So the box that we add should be, where's boxes? 8, 3, which is correct. So let's keep going. Length of boxes is greater, so we go through. Next box, 4 box in current box. So we have the box, which is 8, 3, 9, 3. Is it a wall, or is either of them a wall? No. So we continue. Are we going vertical down? No, we're not. Going across. So if we're going to the left, is the next one an open? Yes, it is. So we are recording that. So we're adding to the next box. What does next box have? Should be 7, 7, 6. Okay, we messed that part up. Okay, so we did do that wrong. Where's that condition? So not this one. This one here. If it's to the left, that means it's negative, so this needs to be times 2. And if it's to the right, then that one's times 2. So now let's run that. So we should have horizontals correct. And we do. Sweet. So we now need to find here. So we just keep going, and now we are at this point. So we're not at that one. We are at this one, and this does look correct. So what box? Okay, what is current boxes? What do I have recorded? That is very wrong. Okay. Okay, yep, so I'm using direction when I shouldn't. So if I am at this one on this one, +1. If I'm here, -1. So now let's restart that, and we'll go through. Now let's go through. Looks like it's working. Go up. Let's skip that and see if it does anything correctly. Very close. Okay, so we will need to restart and go back to that breakpoint I had. Oh, I accidentally deleted that breakpoint. So back to that if statement here. So we're not to that one. Doing the same thing again. Wait, no, that is correct. We want that, I think. Okay, what boxes? 0, 1, 2, 3, 4, 5, 6, 7. We do have the correct box. So this condition is false because this one is connected to this one. So continue. This one is correct. Okay, that's the mistake. So this should be, because we're doing vertical, this one is this one is -1, and for this, it's like that, and this one is +1. Now let's stop that and try run it through it. Hopefully this works. Very close. Okay, so I think I need to change it so, where am I drawing it? I need to make this 0 now, or let's just say dot. Okay, so the problem now is we need to go in reverse order of the list of boxes, because we've got like 1, 2, 3 boxes. So like this one moves to here and it clears that, but then this one moves to here and clears this. So we need to reverse it. So whereabouts am I doing this? So back over here, and this will be for I is equal to length of boxes -1, or then I is greater than 0, I minus. Then this would be boxes I. So that should work now. Nope. So I don't need to do any of this. Let's put this all back. No, I do need this. I just need to switch this around. Okay, so why aren't you working now? So if we restart, and let's go back down to here to this spot. So I is 2. Let's look at boxes. Okay, well there's nothing in that, so we'll go back to here. I is 1, and we grab box. So we would be clearing the current spot on it, and then in the new location we'll be adding it. I may as well just print out the whole grid with this. So we're now to here. So the first one worked, and then the second one just didn't. And why did it not run at all again? Okay, well let's try that again. So go to here. No boxes in the first one. This one runs. It clears it. Now we are printing it. I do not need to, so we're printing it all out. We can see the box moved 1 to the left, which is good. We're now here. Greater equal to 0. So let's go. Got that one. Oh, there we go. Now it's working. So let's start moving our character along. Now if you go up, let's go to here. Let's see, boxes. Same thing again, that is empty. So current box. There's 1 box there. There should be 2 boxes in this. Oh, there is 2 boxes in it. No, there's 1 box. 0, 1, 2, 3, 4, 5, 6. So it's got this box, and then it's got this box. Yeah, this box. So I didn't record this one. So if we run through, it does that. So that means there is something wrong in when we're doing this. So not you, you're fine. Here. Okay, let's go to when we're there. Don't need this breakpoint. So we're now here, and we are moving along. We're now at this position. So we are looking above us. What's the current box? That is 0, 1, 2, 3, 4, 5, 6, and 4. So we have this correct. Is box 0, 0 is above that open brace? No. Is it that? Yes. So we will add this box in. And the issue is because I have a continue in there. Now let's run it. Hopefully that is the solution to the issues we're having. So now let's go through every position. So moved it, down, 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 up. Okay, we were halfway there. Let's just see what it does for the remainder. Yeah, that kind of, yeah, okay, it's getting screwed up now. So that is partially an issue with this and here. This should be box 1. Now let's do it. Okay, now we push that across, that works. We go down, 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 and we push that and it worked. So if we push up, it should not move. Oh, and it didn't. Good. And that should push. Oh, and it did. So with that, okay, so the movement is now working, but we need to find of the larger example above. Not that. We need, where are we looking? So where's the larger example? Did I just go straight past it? Or was that at the very top? Oh, here. So we got this. We'll test it here. Let's get rid of this breakpoint because we don't need it. Let's run it. Okay, well something broke right here. So what should the final one of this look like? Okay, lots broken with it. I thought we had it this time, but apparently not. You know what, let's do this one again. And let's add a few more instructions to test pushing to the right and pushing down. So we'll go up, right, right, down. So up, right, right, down. And see if that gives the output we expect it would. Okay, well that down didn't work, I don't think. Actually, no, that did work, but let's change the printing. So we got this here. So that's the starting one. Then at the very bottom, we show the direction that it went. Okay, that did work as expected. So why didn't it work with that test input? How did this happen? Okay, so I've been playing around trying to figure out where things go wrong, but I found a point where it does go wrong. So as you can see, we've got 3 in a row like this. So this one should be pushed up to here, this one to here, and then this one to there. But when we do that, this one somehow messes up. And not sure why with that. Maybe we need to add a breakpoint in until we reach that point. So let's go through. So I've got it running. I was kind of jumping around all over the place. Okay, what? Okay, what other prints do I have? Okay, this is fine. We don't need that anymore. We'll just have this, and we'll just do that. Oh, I've still got this printed. Okay, so we're now going along, pushing it, and we go up to here. We push, we then align it. Okay, so we've got this. We pushed the first one up, that worked. Then we've got this one, and then that failed. For some reason, it has the wrong... It somehow got the wrong number into it. So okay. Well, I need to put the breakpoint here, so I can actually stop before it happens. And I'm going to move this print for the direction up to here. So it's going down, down, left, left, up. So we're now at that spot. And the question now is, why does it fail here? So let's go through. I still haven't fixed the boxes, so the first one is empty. So we go to here. We've got arranged in boxes I. I has 2, so I've got this, which is 1 box, which is 0, 2, 0, 2, 3, 4, 5, 6. That is correct. And it correctly does that. So we're now here. We are now I1, and it somehow has the exact same. So that is vertical, and that's over here, vertical, and it is equal. Yep, I messed that up. It should be this, then this plus 1. So now let's run it, get rid of the breakpoints, and now it's pushed correctly. Now if we'll keep that. We will grab the larger one, put that into here, and now let's see. Almost. Some are correct, then some are just completely wrong. Okay, so I've been manually going through it with this test one, just pressing F5, going over it, and I found this one right here. So there was a square and square, and we went to the right, but then this one didn't move. It got, it was like this. Okay, so this one moved, but this one didn't. So there could be an issue with the horizontal checking. So if we go to here, so if we're going to the right and we've got this, we're currently we're using 0 instead of 1. That is the issue. So we'll stop that. Now hopefully if we run it all the way through, it works. And if we compare it to the final output, it looks like it is correct. And we got the correct coordinates. So if we go and add the actual information to here, hopefully if we run it, it will then work as it should. Okay, well I need to stop this because it's trying to print everything out, and I don't want it to take forever to run. So let me just... Every place that I've got to print, I need to comment that out. Okay, with that done, now let's run it. Interesting. That number is so close to this, but it's slightly different. So hopefully that is correct. And it was correct. Although it took a while to get this done, I was able to finally do it. So that is day 15 of Advent of Code 2024 completed. If you like this video, make sure to like and subscribe.